Hey everyone, I'm here to talk with you today about how to do a science fair project. And so today I'm just going to walk you through each step. Hopefully this will help you to do your own science fair project and to put all the information on a science fair project board. And I want to, science fair projects are something that's very fun. You can learn a lot of new stuff, things that you wouldn't learn in a classroom. These are things you can research and find out the answers to the questions that you may have about anything in the world around you. So I want to just kind of show a video and we'll walk through each step, and feel free to pause to do your step of the project. I'll show you an example project and you can kind of come up with your question and do your project as we go through each step. When you're putting your information onto a board, I'll kind of show you what a project board would look like. You want to try to put it on a trifold project board. It's kind of what you see right here. This is just a trifold project. This is something that you can buy at any store. It's recommended but not required, but this does help you to put, of course you have a large space to put a lot of information on here. So this is a trifold project board that you can use to put all your research and your procedures and all the things that you do with the science fair project. You can display it on a board. You want to make it real nice, make it attractive to be able to hopefully get your project as a winning project. With a science fair project, a lot of times people say, well, I want it to make it look nice, but really what makes a winning project is good science. You want to have good science in a science fair project, and I'm going to talk about that a little bit later. And so as you're doing your project, kids, make sure you have adults to supervise, because a lot of it can be a little bit dangerous. You will need some help, so parents, it's okay for you to help your kids. Make sure your kids are doing a majority of their writing, typing if you're choosing to type it, put it on a document and type it and print it off and put it on the board. Make sure your kids try to do as much of it as possible, because that makes it their project. And so now that you've been introduced to what a science fair project is, let's now move on to our first step. As you see, our steps are up here. You have 6 steps, and we'll get ready to move on to our first step. Now we come to step 1 in a science fair project. Step 1 is the time where you ask your question. You want to come up with a question that you are just curious about, any kind of topic that you want to know why something works or how something works. So you create a question that can be tested. You can go home and you can do a series of experiments, a series of steps that you can come up with an answer. And so what this question is called a testable question. Here are some examples I came up with. These go across 3 different categories. There are several categories in a science fair, and I've come up with 3. This first question right here, how does changing the wrapping of the wire change the strength and properties of a magnet? This is a physics question. So you're looking, if you like magnets and electricity, this would be a good type of question you want to ask to find out the answer to do a science fair project on. Second one here is, do people have better auditory memory or visual memory? And this is it's a question that you involve people. You do a series of experiments. Do people, if they look at something, can they remember? Or if you tell them something, will they remember it even better? So you're testing a large group of people, and you're kind of see, do people have better auditory or visual? And this is a plant question. Do the number of seeds that a plant produces affect the amount of fruit it produces? So this is a question that you can take a fruit, open it up, take out seeds, and see over a period of time how much fruit it produces. And so these are all questions that you can ask that you can actually test at home. You want to stay away from questions that are just, you can look it up in a book and find the answer, as what type of soil is on the moon. You can just look it up. If there's something that you can go home and you can experiment, you can test it out, then this is the type of question you have. To do our first step, I want to kind of come up with my own question. And my own question I'm going to come up with, I love popcorn, I love eating popcorn, and as I sit there eating popcorn, I ask a question, how does it pop? How does it go from a tiny little kernel to a white, fluffy object that we can eat? How can we not eat a kernel that's hard, and now we can eat something that's fluffy and nice to eat, and it's a good snack? So I want to ask, why does popcorn pop? Before I answer that question, I want to do some research. I want to get on the internet, I want to go to the library, look up how does popcorn become popcorn. I want to find out where it starts. Does it start, how does it start in a cornfield? How does it go from an ear of corn into a tub of popcorn that we can pop? And so to do a question, you want to do some research. So I went ahead and done some research, and I got a lot of information right here about popcorn. I've learned a lot of good facts that I can use to help me with my science fair project, that I can use to explain at the end when I come to writing my conclusion. I can say, this is what happened, this is why it happened. So I got a lot of good research right here. And so, but when I come to my question, this is the first step, the most important part, is I want to ask a question in the format of how I can test it. And so here I've come up with a testable question. My really important question is, which method of popping popcorn is the best? And so there's many ways to pop popcorn. Probably the most common way is in a microwave with a bag. You've all done that. But I want to do it in probably an easier, testable way. And so I'm going to test it by, this is how my mom used to pop popcorn, in a pan on a stove with popcorn kernels, some oil, and you'd pop it until the popcorn popped out of the pan. Of course, you do this on the stove. Another way is through a hot air popper, and this is a hot air popper that you can pretty much do the same amount of kernels, butter, and you can pop popcorn this way. So I want to find out which way, through a stovetop or through a hot air popper, pops it the best. And when I'm asking this question, it's not time to answer it yet. It's not time to try it yet. I have to make what's called a hypothesis, and that will be step number 2. Step 2 is where you make your hypothesis. A hypothesis is when you take your question that you did in step 1 and you make a prediction and you tell, what do you think will happen? What will be the answer to your question? My question was that which will make popping popcorn better or easier? Is it a hot air popper? Is it a stovetop? And I'm going to make my hypothesis, my prediction. And so I make my prediction and I write it down on a piece of paper or type it on a computer and print it off. And this will be my step 2, which is my hypothesis. And so I'm just going to give you an example of a hypothesis. An hypothesis is what I think will happen. And what I think will happen, I think that popping it on the stovetop will make it better tasting popcorn, and it'll even make it larger popcorn puffs. And I can give a reason why, and I'm not going to give you the reason why because you may want to do this project. And in your hypothesis, you can say, what do you think will happen, and maybe tell why. And that'll be a part of your hypothesis. And so this is an example of you making your hypothesis. If you want to do this project, it's okay. Of course, I'm not going to do it all the way through the project because this may be a project that you want to do. But once you have made your hypothesis, you've written it down, now it's time to gather your materials, which is step number 3. Our next step in the process, after you've made your hypothesis, is to gather all the materials that you'll need to conduct your experiment. And I've made a list of materials that I think that I'll need to conduct this experiment. Now this material list, as you'll come to know as you're doing your project, you may keep adding things to it. I have 16 things here, anything from popcorn to the poppers that I'll be using to measuring spoons, a lot of different things, adult help, graph paper, cameras. And so your materials list may grow over time. You may make a working list, and then as you're doing your project, you say, "Oh, I need to go grab this." And so all you do is just go back to your materials list and just add it to your list, and that will go, of course, in a section on your project board. And once you have all your materials, or you think you have all your materials, and you're ready to do your procedures, then you're able to move on to the next step. Our next step is where we actually get to conduct the experiment. This is our procedures step in step 4 of our science fair project. And going back to our question is, what method of popping popcorn is the best? So I have my popping tools set up, my materials set up between the hot air popper and the stovetop popper. I've counted out for each popper the equal amount of popcorn kernels, So I'm going to pop or put the popcorn kernels in each popper, but I want to measure one at a time. So I'm just going to put mine into the hot air popper first. And again, get everything ready. I'm not going to do this experiment. Because this may be an experiment that you want to do. So I'm just going to kind of show you how to set it up. So I got my popcorn into my hot air popper. I'll get it set to turn on. Of course, we could be here for several minutes now to wait on it, but I'm not going to waste or use any of that time to actually pop it. So let's just kind of pretend that we do pop it. So we've popped it there, and you also want to make a chart. And a part of the science is measuring many different things. One of the things that we're keeping the same, of course, is the number of popcorn kernels in each popper. But what we're looking at and what we're measuring is time. One of the things we're measuring is time. And one of the things that we want to measure is how long does it take for that first pop. And not only to the first pop, but what about the last pop? When's the last popcorn kernel popped? That's one part of it is measuring time. Another thing we're measuring is how many of these are left over. We like to call these, let's call these the old made kernels, the ones that are left over, never used, the old made kernels. So we want to see which one is has the most old made kernels. Of course, you want all of them popped because that gives you more popcorn. You always want more popcorn. And so let's pretend I've popped it into the stovetop. I've written down using a timer. I've used a timer counted by seconds because you want to get it as close to the exact time as possible. So you want to count the number of seconds. You press, you write down, let's say it's 30 seconds it takes. So you write down 30 onto a chart, and I'm going to show you what a chart is in a little bit. You write down that first time, and then once it's finished, you press stop on the timer and you write down the time for the last pop. And of course, the last pop you want to stop it because you don't want to burn your popcorn. And so you write down that time. Okay, then you have that information for that popper. Now you take your next one. Let's say you do your stovetop. You take your popcorn kernels, same number of popcorn kernels. This is where you may need some parent help, of course, using a stove, anything electrical appliance. Make sure kids have adult supervision. You take your popcorn kernels, you put it in your stovetop. You have your oil, your butter, whatever you choose to use to cook it with, and then you do the same process you do with the hot air popper, and you measure how long it takes using your same timer to measure how long it takes for the first pop and then the last pop. And then once you have written or gotten all your information, you've written your time down, you want to put it into a chart. And this is kind of an example of what a chart may look like. I have two columns for my hot air popper, first pop and the last pop. I have the stovetop, the time for the first pop, and a time for the last pop. And you want to write this down information onto a chart. And you want to make it, of course, a different chart, or one chart for each method of popping your popcorn. After you have popped your popcorn, you want to put your popcorn into a bowl. You want to put it in two separate bowls. You want to label it. You might want to label this bowl A, and that might be your stovetop. Bowl B might be your hot air popper. And then you gather your more information. You gather your taste testing, or you may look at it and look at the texture of the popcorn. Measure, get a little measuring tape. Oop, I don't know if I have measuring tape on my materials. I need to go add that. So I want a measure or a ruler to measure your popcorn. And you measure it, you look at the texture, and then you have a taste test. You might have bowl A, bowl B, and you kind of ask family and friends, try to get as many people as you can to see who liked the best popcorn. And so you're writing all this information down, you're gathering all this data, and this is all a part of your procedures. You also want to take pictures of this. Take pictures of you popping the popcorn. Take pictures of people reaching in the bowl, measuring it. Take a lot of pictures. You want to put your board, put a lot of pictures of your board. You're actually doing the project. This is kind of your proof that this is your project. This is what you did. And then once you get your pictures on there, make sure, one thing you want to make sure is don't put any pictures of your face. Okay, people eat popcorn. You can kind of maybe get the picture from here down. That's okay, but the whole face, you want to kind of keep those off. You also want to kind of stay away from brand names. If you want to be really concerned about getting a winning project, stay away from brand names. Don't put brand names on there. Of course, you've seen us try to stay away from brand names of different things. You want to stay away from brand names. A lot of, if you really want to move up high into a science fair project, the judges kind of tend to look, turn their head when it comes to brand names. So you want to try to stay away from that. So put pictures, take lots of pictures, put them all on there. Try to get as many as you can of you doing the project. Once you have all the pictures taken, all your steps done, you have all your charts filled out. Now it's time to move on to your results, which is your next step. Your next step, step 5, is where you are taking your data that you gathered from your procedures and putting it into graphs. This is your results section, your results step of your science fair project. This can be, if you like drawing, if you like coloring, if you like working on the computer, this could probably be a very fun part of your science fair project. If the procedures project wasn't fun enough, this can be actually a fun step in your project. When you take your information, you want to put it into graphs, and there's a lot of, with this particular project, there's a lot of things we were measuring. We were measuring the number of the old May kernels, how many were left over after we finished popping, the size, the texture, the taste. We were measuring a lot of things, so we want to take all these things that we were measuring and putting them into graphs. And here's an example graph. Of course, if you choose to do this project, your information might be different because you asked different people. You know, maybe did a different brand of popcorn. There's always going to be different variables that change the results. But I just want to show you what your graphs may look like. Now, these graphs, of course, are drawn. You know, it doesn't have to be on a computer. This can be drawn. You can kind of see the difference, the colors to represent the different styles of popping, the different methods of popping. I have my Y and X axis for my graphs. I have it labeled for what each graph is measuring. And I have the times for the first pop. I have all this information onto graphs, and this is where you get into what's called the good science. You're measuring so many different things. Only one or two things stay the same. The number of kernels in the popcorn stay the same, but there's so many other things that change to affect my results. Which, going back to my question, as to which method of popping popcorn was the best. And here, of course, you should be able to take this information and record your information into your final step, which is your conclusion. Your final step in your science fair project, step number 6, your conclusion. This is where you take all your data, all your information, and your question at the beginning, your hypothesis at the beginning, you wrap it up, bring it all together to write a conclusion. This is, of course, in words, sentence, paragraph form. This is where you're writing. Depending on how much you did, depending on what grade level you are, depending on how much you write. But I'll kind of give you some idea of what to put in a conclusion. You always want to put your hypothesis. You want to restate, what did you think would have happened? Like I said, in my hypothesis, I think that the hot air popper, my hypothesis was I thought the hot air popper would make the best popcorn, or would be the best method of making popcorn. And then I kind of tell a little brief description of my procedures. This is what I did. I took a hot air popper, a stovetop popper. I measured the same amount, just kind of a brief few sentence summary about my procedures. And then after you explain your procedures, you kind of tell the answer. What's the answer? Which one popped the best? And I'm not going to tell you what popped best for me, because I want, someone maybe wants to do this one. I don't want to kind of ruin it for you. However, you may, even if I were to tell you the answer, you might get a different answer, because a lot of times different things happen to cause different results. And then once you tell what happened, the last sentence you want to tell, was your hypothesis correct, or was it incorrect? Why do you think it was incorrect? And of course, going back to hypothesis, back at step number 2, you may find the results and you might want to say, oh, I want to go change my hypothesis. Don't change your hypothesis. Keep it the same. Scientists are always making predictions about what they think will happen. And hardly ever are scientists ever correct. Their hypotheses are always a little bit off or completely wrong. And so they realize, why was it wrong? And that's where you in your conclusion can say, my hypothesis was incorrect. Here's why I think why. And then that's where you bring in your research of why you think it was wrong, or why your results were different from what you thought would happen. And so then you write your conclusion, you type it up, you can write it, you put that on your board, you put all these steps onto your project board, you make it look presentable, attractive, and I can share a website with you that you can look if it's DAS. I know sometimes DAS maybe have a hard time getting things looking nice and neat. There's some websites where you can get some ideas on how to make your project board presentable, so I can share those with you. And there's also a website I could put along with where you're watching this video, where you can get some ideas, more questions than what I share with you at the beginning. And so I hope this video was useful. I hope it was helpful. Hopefully, if you were going with me step by step, you are able to have your project right there in front of you. You have your answers, and you have hopefully an award-winning science fair project.